Good day, cobbers. That's what I should say, shouldn't I? Good day, cobbers. I don't know. How Australian. Um, yeah, I was making, or did make a video about that 4000 and saying how it was a hybrid between the GPs and the GPXs, sort of a hybrid anyway. But I'm working on a 35 at the moment, and I thought that while I've got it apart, I'll point out some things if you've got an older detector. One thing in particular you could probably replace, and I'll just get the case here and I'll hold it round. It's got the name on it, but see that thing there? Everyone goes, "Oh, what's that? Is that a mushroom starting to grow in there or something?" Actually, it's just a water absorber. It's well past its use by date, and yeah, those things basically, yeah, it's all gone powdery and horrible, and basically you could just rip that off easy enough. Yeah, it starts dropping stuff like talcum powder everywhere. So yeah, it won't do anything anymore. It's expanded. It's sucked in moisture out the atmosphere, and it goes in the bin. But what you could do, when you buy stuff and to keep it fresh, well, I get the silica granule packets. I get them in electronic stuff. When I buy componentry from reputable suppliers, and that they know the parts may be going in a surface mounting machine, all the legs and that have to be totally non-oxidized. I'll say won't solder into or onto the boards properly. So they put silica gel. They call it silica gel. It's not gel. It's actually dry, and it absorbs water. And yeah, it just can absorb a huge amount of water, something like maybe 5 or 10 times its size. So you get those things. Sometimes you get them in really good coffee, some food stuff, dry food material do have silica gel in there, and it'll call it a desiccant. Do not eat will be written on it. You get one of those, um, just put some hot melt glue on it and stick it where the other one was. Doesn't matter how big it is. You can shove anything in there. And even on the newer detectors too, it might be a good idea if you could locate some empty space inside the housing and just put a silica absorber inside the detector. Just, if you're out in the rain, or so you get caught out in the rain, and the detector, will pull water in for every little crevice, even though they're sealed. They're not sealed around the switches and the connectors. It'll just suck it in. As soon as the negative pressure, negative, not temperature. Well, temperature does help too, but if there's a negative pressure, that suddenly the outside pressure increases for whatever reason after rain, where the pressure's dropped normally, and you've got water sitting everywhere. It'll just go and suck it in. So you don't want water in your detectors, because eventually it could cause problems, even though these circuit boards are all covered in a white coating. So anyway, here's this 35, and as you can see, that it is a hybrid, where a lot of stuff that is done digitally now and completely differently, like these capacitors. I don't know if you can even see them, the big things, big capacitors there, just before it goes in and gets converted into audio, more or less. Yeah, so you've got in these, you've got a little tiny processor there, little micro. It doesn't do that much. It's connected up to a DAC, and yeah, this one here. Some of these have UARTs in them, some of them don't. That's just for external communication for these connectors here. You could do programming if you knew how to get into it. some people do. But the main thing is you can do programming on these, changing the ratio of transmit, pulse length, receiver turn on and dead time, getting into that there, that thing with the yellow dot on it. I don't know if you can see it there. There, the thing with the yellow dot, that is a EEPROM, and you can get those 27C256 or something, and you can actually read these, and you can reprogram them with whatever you want to put in there. So it's got to be someone who knows how to play PLCs and that, know what they're doing. And yeah, you could actually take it out and put it into a chip reader. I've got chip readers and programmers. I've done a few things on these over the years. Mainly, I used to do it on the SD 2200. We actually got the SD 2200 and put GP timings in it, so it worked fine. So you can do that, and you can do all sorts of mucking arounds there. This one again has the trimmers there, so you can adjust out field by shorting 2 channels and adjusting the other. There's probably a better way of doing it than just shorting out the channels, but yeah, maybe on these ones you could have programmed it here, and it went through a routine where it shut down 3 channels, and you could then adjust the other with a little jeweler screwdriver and just keep working them like that. But on these ones, basically you have to short out the op amps, just kill the gain on them, just go across the gain set resistors, and so they don't amplify anymore. So you could do that, a couple of dabs of solder on it on the back. You can do it across the capacitors, or you could find the resistors. Capacitors are easier to do on there, but I can't remember which ones. It's 2 sets in there, 2 lines of capacitors. You can see them up there. Which ones are which, I can't remember. I think what are they? I can't remember. 15 microfarads, 15 nanofarads for memory. Whichever the 15 nanofarad capacitors are, it's the other ones. Don't do those. So, yeah, I know what it is. I remember now. It's the small ones. They could be just 1 nanofarad or 2.2, right next to. Dear me, right next to the trimmers there. You see where the trimmers are? Get right in. You see the capacitors at the back then? There, see them next to it? They're the ones. So you just short those out. 3 of them and not the other. And the one you haven't shorted out, you bounce a magnet near the coil and null it. So if you do muck around with the spacings, the timings, it's forgiving enough that you can play around and move the frequency a little bit this way and that way. But if you want to be really precise, you get in there and you null out the earth field just by bouncing a magnet, probably I don't know, half a meter away from the coil. If the coil's flat like this, just up and down here like that. So just null out the change in tune, of course. So it's not going woo woo woo. It just sits there and purrs. So on these, yeah, there's a lot you can do to these older detectors. As you can see, there is not a lot of processing done, locked up in something like that. This thing here, if you actually have a look at it, you'll follow that a lot of the I/O lines just go to the switches and stuff like that. So it may do a little bit of other stuff. I don't know. It's basically, I think it could be more or less. This is only me guessing because I've got no idea of the code because I didn't write it, and it's code protected, so you can't get it out. Well, you can get it out, but it'll cost you a lot of money. You have to send it over to China, and they'll do it for you. But don't do that. They've already done it anyway. as we know, they've probably already done it anyway. They're making 4500s and calling them everything under the sun. But you talk to the Chinese and they say, "Oh yeah, it's our design." They're bull dust. It's not your design. You stole it, or you bought it off. the CCP operatives that were raiding the military secrets of Khotan years ago. And all the design for the 45 came along for the ride. So we know what happened there. Well, how else would the Chinese know how to make them and program them the same way? Terrible, isn't it? Except they're not as good on the parts, especially the quality. We can say that. I know that for sure. So something like this. These are really good, capable detectors. Limitations are that you can't really adjust the gain, which is quite critical. I don't know why so many detectors. If I say this is going to come out in the next model after the next model, if you know what I mean. Front end variable gain with tracking on both channels, so they're both equal. You don't want one up here and one up there because it does use both for mono, and you want them to be absolutely, all the DC offsets and everything, so absolutely identical in electrical performance. So yeah, as you can see there, if I hold it around there, this is the same in most of these detectors anyway. This part here, see that little op amp there and that one there? That one there is used in double D only. It doesn't use that one. It's turned off by a multiplexer further down on its output, and that's the double D one. That's the only one that works for double D. When you go into mono mode, it uses both in parallel. So both inputs go through various switching circuitry and get combined on the output through the multiplexer. It's all quite pedestrian. I've been doing so many GPX 5000s and 45s, I've got to sort of throw myself back to look at these. But, if you have a look here, I think for memory, that's the multiplexer chip there, where the signals go in. That switches all functionality for receive turn-ons, transmit turn-on. That's just a ADG 333. It's tons of pedestrian type chips in these, and they're fairly reliable. And if you have a look at the 5000s and 45s, 48, whatever, and all the other GPs, the power supply here, this is all the power supply switching. It's identical. The same supervisionary ICs in the power supply here. There's not much difference there. Done things differently. Like there's a whole swag of components on here for the audio, all little surface mounts and that. But it's only a quad op amp and some other ancillary stuff there. Doesn't put out much power. But overall, these are really good as a backup detector. And if you put variable gain into the detector, you got to do it properly. You can't just go and stick a pot in there across the op amp or something and say I'm going to vary the gain, or use a twin gang pot in the input. It'll go pear-shaped. Don't do stuff like that. I have seen it done. I've had to pull it all out, and I had to redo it all. But these detectors, really, you think about it, right? What's your limitations when you go detecting? And because on these, you just got basic variations of normal mode. And, that's the detector we're talking about there, which is upside down, of course. But, there we go. That's it. They're all much the same. Different filtering. If you go look at it, that's a 3500. If you go look at a GP 3000, you go, well, I'm looking at the same thing, basically. There are a couple of little bit extra things. I've got a really dry mouth. Oh, you probably noticed too, I've had a shave, and I missed a couple of bits here somewhere. But anyway, I'll get them later. Should have had a brighter light in the bathroom, but not the case. So that's the 35. There's plenty of room in here. If you have a look how it sandwiches together, There's tons of room in there. So, behind the wall, do it around, I don't know, do it around that way maybe. But yeah, it's quite hollow in there. There's enough room to throw a party. Around in here, um, some people make the mistake of putting stuff in these as well and putting it up near the micro here on this board. And it causes a lot of interference because the thing's sitting there going, making square waves basically, and it couples into anything you put there is trying to do low noise, something or other. So you got to keep it down flat. It's these are good detectors, and I'll tell you what, these are going to start getting rare. I just know it that they're going to get rare because of as time goes on, there's all these new fandangled detectors come out, and this stuff is thought of, oh, that's old, and sorry, you can't get any performance out of it. No, that's not the case. These can be upgraded greatly, and we can put in variable frequency, and we can put in variable gain. There's you can put an extra switch in there for a different sensitivity mode, which changes the little EEPROM data. There's some extra data in there, and you can actually tap into that. So it's quite interesting overall. And I'm just staring at it, just trying to think of what else you can do to it. There's a lot you can do to it, really. Basically, give one of these some variable gain. Just put a variable gain board in there, and give it a good tune up, match it all up, adjust things. Things do wander over time, so you can probably redo all the earth field on it at your center frequency if you want variable frequencies. And that's a very, very capable detector. Tell you the truth, in normal timings, normal mode, these older detectors, any of the GP series, only in normal timings we're talking, as a comparison, if you get one of these in normal timings, it's the same normal timings that's in any of the GPXs, except for the 6, of course. It's totally different. But the normal timings in the 45 and the 5, and I'll tell you this, if you get one of these, just stick it in normal timings and use the same coil and compare it to a GPX 5000, factory stock in normal timings, you'll say to yourself, what's wrong with the 5000? It's deaf as a post. And they are. they're deaf for a reason, obviously, probably to make it quieter. I think that they were sold on the promise that they were quieter detectors. Well, we can make your car quieter too by shoving newspaper up the exhaust pipe. That'll make it quieter. But no, I'm just mucking around. But you get the gist of things. It's done in a different way. It's done in the front end. So, how about we cover half your carby? Would be, you get less power output. It's not power output, but it's input power and amplification. But I'm trying to say it in a roundabout way without being too obvious and too whatever. So you can muck around the gain of these too. Not that you really want to. The gain of these is set fairly high, and these are. I'm expecting someone to come. I just saw a car go past. The gain of these are all set at front end gain of 48, and like I said, with the 5000, and the newer of the 45s, the old ones, not the first edition, but the last edition, all the gain on those 34. So work that out for yourself. You can probably calculate in decibels, so it's a little bit under. Let me. I'll just do a quick mental calculation on it. 70. Yeah, it's about 3 decibels more, which is twice the power. Well, on twice the input power, twice the receive ability. But you got to remember too that also brings in noise. The other thing too, there's also what you want to call, well, I'm not going to go and call it Nyquist noise or something because you won't know what I'm talking about, but all resistors generate noise, and in these, I mean, you got a 470 ohm resistor as your feedback resistor, and that itself will probably generate what probably around about 3 nanovolts of noise just in the resistor. And on these, you're using op amps that are, basically you could say they're meant to be 0.9. So the noise figure of the actual device is exceeded by the external componentry. So there's no benefit, technically, textbook wise. So there's other ways of getting the noise down, but we don't have enough op amps in here to do it. So we have to modify it where you can run the gain really low if you want to, if you've got really noisy environmental EMI, or absolutely super pain in the proverbial hot ground. And I still to this day am trying to come to terms with why it has not been done on the input stages where it's critical, not in the back end, because after the front end's all saturated with hot ground and EMI, this is going to do nothing because this is jammed up, you can't unjam it. So if you can actually pull this down, so you now have, there's a signal, not jammed up here going, or whatever. You can now, alter your gain here, using the gain control on the detector to set where you want to have it, basically. So you can have a balance here and a balance there. So you've got 2 gain controls. The ground's really hot, just bring that down a bit so you're not sitting there getting your ears pinged off. And you can probably drop that a little bit too to compensate, or that, or drop that right down and bring that up. There's all sorts of combinations, but I just bamboozle me why it hasn't been done. So yeah, you can ask your friendly dealer why metal detectors don't have variable input gain, and in a lot of cases too, the new detectors are probably overcoming some of that, but automatic settings, I don't like automatic settings to a degree. I'd rather be able to listen with my ears. This is the ultimate filter. And if it's the detector's gone AWOL and it's doing something, thinks it's something else or whatever, who knows? Who knows? I'm just saying, I don't know for sure, but it is a possibility that you could go over small gold in bad ground and it just dumps the gain down, you don't hear it and you walk off. Or could happen on a big target signal. I have, if I actually say what I have observed with some detectors, I will get so much flack. So I'm not going to say anything, right? There's some detectors out there, and I'm not going to say the brand or the make or anything like that, but I don't know. Well, the operators are pretty good. They've been doing it for years and years and years, but they just walk over gold, and along comes something else behind it and picks up what they miss. It's absolutely mind-blowing. So you can piece that together yourself, or have a wild dream of what detector and what detector. But everyone's going to say he's talking about us. Prove it. I'm not talking about anyone in particular, but there are detectors out there that, even though they all sound great and all hyped up and all the rest, they don't get every bit of gold. They still have areas where certain particular size. Well, this is me sort of. How do we say it? Just my opinion that they still fall into some type of detection. Or ground balance window, we'll call it, or something of that nature. It gets nulled out. It's a baby with the bathwater. Chuck it out. Trying to get rid of the bathwater, but the baby's still in there. It sort of didn't filter out the baby. It should have filtered the the baby and you still got it. But you know, it's just the nature of the beast. You know, sometimes as well, and you probably, a lot of these seasoned guys will know that if you go detecting in summer and you have a patch, you'll go over it and over it and over it, and you'll say, oh, I've got all the gold. You go back over in winter, and you go, where'd all those nuggets come from? Right, it's true. Uh, Cooler ground, less thermal noise. Cooler coil, less thermal noise in your coil winding, even though it's really low resistance, depending what detector you're using, of course. Um, all resistance, all resistors, all make noise. And someone is trying to call me. So yeah, they are. I better see who it is. It might be the person who's meant to be coming around. So I'll leave it there and catches.